Welcome to week 10. We're learning about object-oriented inheritance, and this will round out our introduction to object-oriented programming. I'm excited to teach you this lesson. This is some of the stuff that makes software design incredibly fun and enjoyable. And so let's get started with a quick example. We're going to run through this example and do some interactive stuff with a demonstration, and then I'll get to doing a demonstration of something very similar to our assignment for the week. So you can see here on the screen, I've got a parent class defined. We're going to develop this example where we have a parent class and it's got a few attributes. We'll come back to that in a second. There will be a child1 class that inherits everything from parent and adds one more piece of data to it. There will be a child2 class that inherits from parent, and it will also add its own child2 data. And then we'll have a third class that actually child3 inherits from child2. So it's like the grandchild of the parent class, and it adds its own data. We're just going to use these quick examples to illustrate some of the principles of object-oriented, the encapsulation, how it relates to inheritance. But let's take a look at the parent really quick. Our parent class has a number and a description. One number is an int, a description is a string. You'll see here that we have a single constructor that takes the number and the string and sets it in the fields of the class. Nothing exciting here. There's a getter for the number and a getter for the description, and we have a toString. Now you'll notice that I have an @override annotation. While this isn't technically required by the Java programming language, the Java tools that are out there like to suggest that we put this annotation on here for clarity, and so we do, because IntelliJ will nag you until you do. So we put that there, and it's really to help us understand and help anybody else looking at the code or the documentation around the code that we intend for toString to override the parent class. What's that? You say, what parent class does parent have? Well, in Java, all classes inherit from the Java base class called object. And so object has a few methods that we'll see in just a second that it provides. And one of those methods, so every class in all of the Java libraries that we have available to us will have a toString method because it's defined by the object base class. And so if we want to provide a custom toString method, then we have to override it, and that's a term you'll learn in the chapter this week. We're going to override it, same name, same parameters. In this case, there aren't any parameters, but a different implementation between a parent and a child class. Different than overloading, where it has the same name in the same class, but it's a different set of inputs. Okay, you'll see our child class, it also has the same things, but there's something interesting to note here, that the child class, when we create an instance of a child class, we need to fully understand what makes up that child class because it has everything the parent has. And so we actually need to supply the inputs for the parent too, the number and the description. So our child class constructor actually has parameters that we pass along to our parent class constructor when we call super. Super is the keyword that says, call my parent constructor with these parameters. And I get child data and another override here on toString because our toString method is actually going to be different than our parent class. Our parent class's toString method just prints out its number and description. But the child, we're going to print out our parent's information by calling our parent's toString method, and we know it's our parent's toString because we use the super keyword, and then we tack on our own child1 data. Just going to grab this line because I know how I copied and pasted to create this example, so we're going to need it on all of them. Again, it's not producing an error because it's not technically part of the Java language that we have to say @override, but a lot of the software tools like IntelliJ or Visual Studio Code will nag us and tell us that we forgot to annotate it with an override. But so that's all we're doing. But you'll see here, and we're going to update, say, our child2. That works. Our child3 needs to provide our child2. So we're going to say child2, and then we'll add our own description for child 3. So we're going to call, I take that back. I confused myself with my own example. Because child 2 incorporates the parent's output, I don't need to incorporate the parent's output again, or the parent, my grandparent, because I'm going to inherit that from here. So my parent is actually going to show up as it'll have both my parent's data and my child 2 data. And then we'll tack on our own child 3 data. All right, so that gives us a quick overview of our classes. We're going to come over here to our demo, which has a little main method that we can then start playing around with. So if I pull off here and I create a new object, just a plain old java.lang.object, I'm going to say object 01 equals new object. And that's really all you can do with it. But let's see what 01 has available to it. It defines an equals method and a hash code method. And there's our toString that we're going to use in our demo. There's a get class, and that'll actually return another object that tells us everything we want to know about the class itself. And that's one thing that Java can do for us, is we can inspect our data types at runtime. And the get class method is the gateway into that whole world of the internals of Java. Notify, notify all, wait, and a couple of different overloads of wait. And the notifies and the waits are related to synchronization and multi-threading. We're only going to concern ourselves with the toString today, but we do see that 01 has a toString method. So let's just call it. And let's print this out so we can see what it does. And so if I run this, I'm going to see some output. And the output is going to underwhelm you, honestly. There it is. So Java's object doesn't know anything about anything else other than I happen to exist at this spot in my memory somehow. And so you get a very simple toString method. So of course, when we have our parent class, we want to have something sensible as our toString method. So we're going to have to override it and provide something sensible. So let's see how that works if we create a parent class. Come back to our demo. Now we can get rid of this. And we're going to say parent p equals new parent. And of course, our parent wants an int. So we're going to give it a 1 and a description. And we'll just call it parent for now, lack of creativity. System.out.println p.toString. Let's see what we get here. Okay, there's our 1 and our parent. And let's take a look at our how we implemented that. We print out, we format it, a number and a description. So that's exactly what we got down here. Little word to the wise here. Our toString method should not do any system.out.println calls in the toString. The toString is expected to only return a value and to not have any other type of output that's going to be associated with it. So just a little tip there. Don't do any system.out.printlning in your toString unless it's just a debug thing to see if it's happening right. But there are better ways to debug than that. So now we can see that we've created our parent class and we've called its toString method. So let's do this really quick. Let me show you how one little shorthand that Java gives us. This is actually not a problem. So one thing that Java will do is anytime you have an object that needs to be represented in a string context, like in this case, system.out.println expects us to pass it a string. We pass it an object. And so what Java will do is it'll say, oh, I see that you've given me an object. I'm going to call its toString method. And it knows it can do that because every object in Java has a toString method, even if it's that default one that prints out nothing sensible. So if I run this, I should see the exact same output, because what happens is my toString method on my parent class is going to be called automatically. And we can actually watch this happen if I stick a breakpoint right here, and then I come over here and I debug my inheritance demo. We're actually going to stop in our toString method. See that? We got called, here's our call stack. Our toString method got called by some value of method on the string class. And the printStream class, which is our system.out, has the printline method that we're calling. So printline looked at that and said, oh, I probably want to make sure I'm getting the string value of this object, not the object itself. So it called value of, and value of called our toString. So there's proof that when you need to treat an object as a string, its toString method will get called. All right, so we'll just continue and end there. So that's all fine and dandy. So yeah, now we've covered the last 2 weeks that we've learned about objects, but what's all this stuff about inheritance? Okay. This is where things can get fairly interesting. So let us now get rid of our parent, and we're going to create a child. Actually, no, let's leave that parent there, and we'll leave its output there too. So I'm going to create a child. So we're going to say child1 C1 equals new child1, and it wants the child1 data and the number and the description that will be assigned to the parent. So I'm going to say, I'm going to call this C1 data, and then my number, I'm going to say 2, and my description, I'm going to say parent 2. And what I'm expecting to show here is the parent of child1 is not this parent class here. This is a separate object, totally separate. So this child1 has its own parent that's number 2 and parent 2. So if I do a system.out.println on my C1, let's see what I get. So we'll see the output from our parent class, our first one, and then we see that we have another parent object, but it's 2 and parent 2 with child1 data as C1 data. So we've got 2 separate objects and 2 separate parents. Just because something has the same name doesn't mean it's actually the parent of the next object we create. So let's take one, let's do a little inspection here on our C1. If I hit C1 dot, now I can see a lot of things here that are available to me. I see number is available to me, and we'll talk about that in just a second. I can see I have get child1 data. Yep, that makes sense because that was defined in our child1 class. ToString is also, we overrode that in our child1 class. And then there's a get description. Now wait, get description. I don't have a get description in my child1 class. All I have is a get child1 data and a toString. So where is that get description coming from? Well, the get description is coming from the parent class because child1 is inheriting everything from the parent class. And we know it inherits from the parent class because we say extends parent. And the reason that number showed up in this list of things that are available in the C1 object is because number was declared to be public. Now, this is not a great example of good software development. We would normally make this private with a getter on it. We've got the getter. But I wanted to leave it public to illustrate that point, that we don't actually see a description immediately available in our C1, right? Because that description is not public, it's private. The only way to get the description is through that public accessor. And so that makes a little bit of more sense why we would have public and private and what it actually means. And then of course we see our get description, our get number, these are inherited. And it's hard to tell in IntelliJ, but these are not bolded because they're inherited. And the bold stuff are the things that are immediately defined on that class that we're working with. So you can see equals hash code, get class, notify wait, etc. And toString is bolded because we provided our own copy of toString, our own version of it. All right, so let's take a look at what C2 does. So C2 child2, C2 equals new child2, and we're going to pass it C2 data, and the number, the parent number is going to be 3, and the description is going to be parent 3. And then I can system.out.println, and I'm going to pass in C2, and of course we'll see that everything works the way we expect. So there we go. Our parent 2 has, there's our first 2 lines of input, our parent 3 with child 2. So I want to make this point very clear because this tends to catch people. The child class has the parent class a parent. It extends parent. Same with child 2. Child 2 and child 1 are not really related to each other than the fact that they have a common parent. At runtime, when I create an object of type child 1, it's not sharing the same parent class with or same parent object as child 2. So when you create a new object that inherits for something, you get all of the objects that it inherits from built into its memory. And so child 1 has its own parent object that happens to be a parent class, but child 2 has a different parent object built into it, even though it happens to be the same class, so we can program it the same way, but in memory, they're 2 totally separate data structures. Now let's take a look at child 3, which we know inherits from child 2. Oh, actually, let's look at something in C2. In C2, we see get child 1 data. How did that work? Because I forgot to rename my method when I copy pasted. Let that be a lesson to you. When you copy paste, you're gonna make mistakes. The more complex code you copy paste, the more chance you're gonna have to make mistakes. I just got stung by my own attempt to be efficient, but instead I was careless. So C2. Now this example looks better. So C2 has a number because the number from the parent class is public, so C2 inherits that as well. It has its own toString method, and then it has a get child 2 data, but it doesn't have a get child 1 data anymore after I cleaned it up. But C1 does have a get child 1 data. So C2 and C1, they inherit the parent stuff, but they don't relate to each other. Let me just make sure. Yeah, child 3 I corrected. So we'll get there in just a second. So C2 and C1, neither of them has, or they don't have each other's fields because they're not the same thing. They have a common parent, but they themselves are not equal to each other. All right, child 3, C3 equals new child 3, and we're going to give it C3 data. We're going to give it C2 data X to distinguish the data from our C3 data from the data 2 that we have to pass up. We'll talk about why we have to do that again in just a second. And then the number 4 and the number and the parent 4. So if I do a C3 and I look, you can see I actually see the get child 3 data because that's right there. I have a number because I inherited that from my parent and it's public. I have a toString that I've defined myself in my child 3 class. I have inherited get description and get number from my parent, and I've also inherited get child 2 from my other parent. I guess I should call parent my grandparent, and child 2 is now my parent. So I inherited everything from that. So as you inherit, as you create a long line of inheritance, you inherit everything all the way back. And let that be a lesson to you that there's something about Adam and Eve in every single one of us. How's that? We inherit something from them. And of course, as children of God, we inherit something from him too, which is the potential and the ability to overcome. So, okay. Child 3, let's print this baby out and see what we get. System.out.println C3. Okay, now let's take a look at how we built our toString method in child 3. In child 3, we ask our superclass, which is child2, for its toString method, and child2 toString method calls the parent class for its toString method. And so we've embedded grandparent, parent, and then ourself into our toString, and we can see that here. So my parent is made up of the grandparent class here, and then the child2 stuff here, and then we finally throw our child3 stuff at the end. So because of the way we wrote our toString, this doesn't happen magically for us. It's not automatic. We had to write our toString method specifically to pull in our parent. Sometimes we want to do that, sometimes we don't. In this example, I wanted to show it because it shows you how a toString method can call another toString method and incorporate its output into the output for the first one. Okay. I want to talk about these constructors here. You'll notice that the child3 constructor has to have data for all of the parent data, both its immediate parent and its grandparent. And the reason is exactly what we talked about. When you create a new child3 object, when you create a new child class from any that extends from any class, you're actually creating all of its inherited classes all at the same time. So your object actually, even though it's nicely wound up for you by our development tools, we have to create everything. We have to initialize everything. And that's one of the benefits and one of the sidetracking problems of object-oriented development. Inheritance can become very inflexible. And the benefit is if you work in an industry where that inflexibility saves you from making mistakes, then it's very beneficial to you to require that when we create a child that we have to also provide everything we need to know about the parent as well. There may be another, and examples of that industry would be the safety critical. So aerospace, automated cars, all of those things. The software development discipline needs to be very rigorous. And so we would see a lot more opportunities for inflexible inheritance where that's a good thing for us. There are other industries where that's less important. And so we're more worried about having the code be a little bit more flexible. So I'm going to do one quick exercise here to make this code a little more flexible. And then you can see what's going on here. But with that flexibility comes more responsibility, personal responsibility on us, where the compiler is going to say, sure, I'll let you do that. I don't care if you put correct values in there or not. So if I come back and I create an empty constructor for my parent, I could say public parent. Well, let me explain why I would need to do that. So let's go to child1 really quick. And if child1 does not call super, I'm going to get an error on my constructor. And the error says there's no default constructor available in parent. That means Java is telling me that error message is just a funny way of saying, I don't know how to create your parent class from here because you're not doing it and I don't see anything here that's going to let me do that. And so if, for example, I just create my data for my child1 class, how do I know what to set on my parent class? So that is a little bit of a problem. And that's the problem that we're hoping to solve by providing a default empty constructor on our parent class. And so we're just going to keep our number will be initialized to 0, and our description will be initialized to null. And at this point, I'm going to change this to private. And we're going to need setters for our attributes. Otherwise, there's no way to ever set them. So we're going to do public void set number, int number, this dot number equals number, public. I like to put my setters after my getter, so public void set description string this dot description equals description. Okay. And also, this is a quick and dirty example, so I don't have comments on everything like I should, but hopefully you're following along. So I have, now I have this empty constructor, and this will allow me to have a much simpler constructor in my child classes. So my child classes, I can get rid of my parent data, and I don't need to call super, and that just made this class a whole lot simpler to read. And I can do the same thing with my child 2. Now my child 2 is coded pretty much exactly like my child 1. I just wanted to have 2 siblings. My child 3 now depends on my child 2. So my child 2 is going to have a default constructor. And we're going to have a set child 2 data. Public void set child 2 data, string data, child 2 data equals data. And that frees us up now to clean up our parent constructor, or our child 3 constructor a little bit. Okay, so now this seems a whole lot easier. If I go back to my inheritance demo, now I have errors because I've created all these things with different constructors. So child 1 doesn't need to pass the parent data anymore. And child 2 doesn't need to pass the parent data, and child 3 doesn't need to pass the parent or the grandparent data. So now if I run my output, so take a look at this output and let's see what's going on here, because this is going to illustrate the responsibility that comes with having more flexibility. We'll run this and take a look at this. Our parent object up here that we created, it's what we expect. But the parent object built into child 1 or inherited from child 1, we never initialized it, so it's got all those default values, 0 and null. Same for child 2. And then for child 3, I've got my C3 data because I set it here, but my child 2 is null and my parent is 0 and null. And what happened? This is going to be a problem on your assignment because it happens all the time when you have the flexibility of a default constructor. And again, I would tell you that there are some industries or types of software that you can't afford to let programmers be responsible for themselves. And so you have the compiler enforce it by having very strict constructors, and we wouldn't have a default constructor that lets programmers be a little more flexible. And I guess flexible sometimes turns into careless or lazy. So what has to happen here when I create a child 1 is I need to then populate the parent data that comes along with child 1. So I'm going to say C1. Now I don't have to call it parent. I can say C1 because it inherits everything. C1.set number. And what did we call that one? Was it 2? And we're going to call it parent 2. Oops, can't do that. C1.set description, parent 2. So if I run this, then our parent line here should go back to the way we expected it. There we go. And so with my child 2, I can do the same thing. I'll say C2.set number 3, C2.set description. We call it parent 3, right? And then if I run that, we'll see that our C2 comes up because it's coded exactly the same as C1. And now our grandchild class, C3, we're going to do a C3.set number. Again, this is on the parent object built in or inherited from child 3. We're going to call it number 4. C3.set description is going to be parent 4. But we also have to set the child 2 information. So we're going to say C3.set child 2 data. Call it C2 data. And now I am ready. And we've restored our output, but we had a lot more coding we had to do, a lot more responsibility, and our program didn't care whether we set it or not. And so the way our assignment this week is structured is you're actually going to have to be responsible to set things up the right way. If you don't, you're going to lose points. That's why I'm going over this. So we have constructors that can either be flexible or inflexible, and that's not either good or bad. It depends on what you want your software to do for you. But inheritance brings a level of inflexibility into our software. And there are other ways that we have learned to write software that mixes inheritance and a concept called composition that is extremely powerful and gives us a lot of the best of both worlds. Unfortunately, in our class, we're not going to really dive into how to build an application using composition over inheritance. But our final project, you'll see a lot of the samples that I give you will kind of do both. You'll see how we can use objects that provide behavior but aren't part of the inherited structure. Okay, so that's our demonstration. I expect you can have a lot of questions about this. There's two ways that you can address your questions, and I hope that you'll follow both ways. First, I hope that you'll sit down with your IDE and write some sample things and test some ideas out yourself. Type them up, look at the error messages, see what you can understand from what you're seeing and see what sense you can make of it. And then second, please ask. Please ask in the discussion boards. Please send me an email, text me, whatever you need to do, talk to the tutors. We will help you understand this. This is all very abstract stuff. So here we go. And hopefully when you come back to watch this video, if you are brave enough to watch it more than once, I hope that you're not simply looking at the words on the screen to try to figure things out. I hope you're listening to the descriptions that I'm giving you, because I think a lot of the understanding that comes about how things are working is in what I say, not in necessarily what you see on the screen while you've paused the video. That's just a little tip. I think you'll do yourself a service by listening along with watching the video and just paying attention to what the explanation is, and not so much what you're seeing as both what you're seeing and hearing. All right, so get off the soapbox, and now we're on to our demonstration of how you can accomplish your homework assignment. So the homework assignment for week 10 is to develop a triangle class that extends the geometric object class that is demonstrated in the chapter in the textbook. So I have gone to the trouble of creating that geometric object class, and I guess I'll walk through it really quickly so you can see it, but I don't want to spend so much time on it because we're already 35 minutes into this video. So our geometric object, this is straight out of the book. It has 3 properties: color, filled, and date created. I've made them protected so they're available to be accessed directly by the child class, but we could make them private too. I wouldn't want to make them public, but we could make them private. Date created is a date. I have a geometric object constructor. This is a default constructor, and the only thing it does is it initializes the date created to a current timestamp. So a new date without any parameters just takes the current time immediately right now and puts it into a date object. And then it's just a timestamp. It doesn't change as time progresses. It's that timestamp when it was created. Color is already initialized up here to the string white, and filled booleans are already initialized by default to false. I've got a second constructor that takes the color and the filled. So this would be a convenience constructor, and you'll see here I call the other constructor to get its behavior, so I didn't have to duplicate the new date stamp in case there was something complex about getting a timestamp. In this case, there's not something really complex, but I didn't want to duplicate code. So I call the code that's already written, and then I set the color and the filled based on what was passed in. I've got getters and setters for my properties, and then I have a toString method that prints out the stuff from this geometric object class. So next, we have to define in your assignment, you're gonna do a triangle. In this example, I'm going to do a rectangle. So if I pull up my UML model, what we see here is here's our UML for the geometric object. Here's the UML for the rectangle. It's got a length and a width. In your triangle, you'll have 3 sides: side 1, side 2, side 3. I'll have getters and setters for everything. And I will have the default constructor, I'll have a constructor that takes everything for the rectangle and the parent class, and then I'll have a getArea method, and then a toString method. So let us run through and create our rectangle class. So we're going to say new Java class rectangle. And all classes that we implement in our assignments have to have a comment. So the rectangle model, that's really all you have to do, but I require it to be there. Our rectangle is going to extend geometric objects. So now it's got all sorts of stuff that comes with it. It's got those 3 properties and the toString method. And we're going to add to it a, what did we say in our model? They're doubles. Oops. So we're going to go doubles. So private double length, private double width. So we have a default constructor, public rectangle, and its job is going to be to call the default constructor of the parent class. So super, and that works out just great. And we'll have a parameterized constructor, public rectangle, and it's going to take the double length and the double width. And then our parent requirements, because this is the inflexible part, so we have to create our parent object within ourselves. So we know that there is a color and a Boolean for whether or not it's filled. So we'll go ahead and pass our color and our filled up to our geometric object parent, and then we'll set our length and our width in our own memory space here. And then I'm going to be a little bit lazy here in the interest of time, and we're going to generate our getters and setters. So we'll go to generate, getter and setter. We're going to select both of our properties there, and that took care of that. Of course, now we're modeling good behavior. We've got our default constructor. All right. We don't necessarily have to calculate or put comments on our getters and setters. They're trivial. We know exactly what they do. But our getArea, we're going to have a public double getArea. So this is something, since our geometric object class doesn't have an area that it knows, it doesn't have dimensions, can't have an area, so it doesn't define a getArea method. But now that we know that we're a rectangle with 2 sides, we know that we would know how to calculate an area. So we're simply going to say return length times width. Very simple calculation there. The calculation for the triangles area that you're going to have to do in the assignment is a little more complex, and I've given you the code for it in the code samples board. So go ahead and grab that. It's also in the textbook, but I think it's going to be a little bit easier if you just grab it. And I don't even care if you understand that calculation. It's math, but it's very helpful to have it. And please notice that there is a caveat. If you've got weird triangles with tiny angles because you've got really long sides, then the math falls apart and you might end up with not necessarily the most accurate area calculation. Calculate the area of the rectangle. And then finally, we're going to have a toString method. So we can say at override public string toString. And there are some purists that say you should have a documentation comment over your toString, but because it overrides the parent class's toString method, and our parent class geometric object overrides the Java default objects toString method, it's going to inherit the documentation for that too. So it's up to you whether you want to do a comment or not on that one. But this one we're going to return, and I like to use string.format when I'm building up strings, string.format, and we're going to say %s, And then we'll say area equals percent dot to F. That'll be our area output. And our first %s is going to be our parent. So we're going to say super.toString. That'll pull in the geometric objects toString. And then we'll do our own stuff here, and we're going to call get area. And the value that it returns will go into this floating point placeholder right here. So that is our rectangle class. That's pretty cool, isn't it? So we're going to now come over here and create our w10.example main class. w10.example. We'll put a comment up here, demo for week 10. And now what we have to do is prompt the user for the values. I'm going to make it simpler in this example because I just don't want to do the whole assignment for you. Make it too easy, of course. I think you need to struggle through some of that to make sure that you learn it. I'm not trying to be mean. I'm trying to help you learn it. But in the assignment, you have to read in the values for 3 triangles. I'm going to do 1 rectangle in this example, and I'm going to leave it to you to use your understanding of loops and methods, and maybe even a combination of the 2 of those, so that you only code that input logic 1 time. I do not want to see the same input logic 3 times in your method, because I will take points off for that. You should know how to do efficient coding by now. So I expect you to have questions about that, but please don't turn in an assignment next week that duplicates the same prompting and inputting code 3 different times in your main method. I want to see some efficiency there. But we have to, let's just make a quick note of what it is we have to input. So input, we need the length, the width, the color, and the filled. And the date, the timestamp, gets created on its own. So here we go. We're going to need a scanner. Say try scanner input equals new scanner based on system.in. This is our old friend, or a nemesis, I guess, depending on how you look at it. We'll import our scanner, and now we're going to prompt. And I could be crazy with my prompt, and I'm not going to, but I could actually write a method that would prompt the user. I could pass in a string and it could return me a string, and I could convert it. I'm just going to use the straight up here just for the sake of time. So here we go. System.out.print, enter the length of the rectangle, and then we'll say, I guess it's a double. So double length equals input.next double. Again, I'm not going to break your program yet because we haven't learned about how to handle errors yet. That'll be next week. And then I'll do a system.out.print, enter the width of the rectangle, and we'll say double width equals input.next double, system.out.print. What's next? The color, enter the color, string color equals input.next line. We're going to read to the end of the line to take whatever the user types in, because if they happen to type in something that has a space in it, then it'll only take the first word as the color, and then it'll leave the rest of that line as the input, and we're going to ask for the color next. So I'm just going to read to the end of the next line and trim whatever I got. And of course, I need to do some error checking in all of this, and which I will do in just a second. And then the next thing is going to be the filled. So system.out.print, is this filled, yes or no? And we're going to read this as a string, and we're going to convert it to a Boolean with a little bit of logic in just a minute. String filled equals input dot next line dot trim. So I'm just going to read whatever the user types in again. And now I've got my input values. And so we need to do a little bit of error checking. We're just going to walk down the list of error checking, and we're going to say if length is less than or equal to 0, or width is less than or equal to 0, then we're going to print an error message. System.error.println length and width must be greater than 0. And we'll exit. Now let's check our color. And the only rule on our color input this week is that it can't be empty. So we're going to say if color equals null, or we've already trimmed it up here at the top. So we're going to say or color dot length is 0. Then we'll say system.error.println color must not be blank. And then we'll exit. And then finally, we're going to check our filled before we try to do anything else with it. And we're going to do the same logic as we did for our color. So if filled equals null, or, and we have to check for null first before we try to call the length on it, because if it's null, then it won't have a length method and we'll get an error. So always check for null first, because Java actually evaluates from left to right. So, and we call it short circuiting. If this happens first and we have an or condition, then it doesn't matter which one is true, if either of them is true. So it'll stop on the first one that's true. So we can use that to our advantage. So we'll check for null first, and then we can, if we're not null, then we're going to proceed and evaluate the other side of the or. And so then we're going to say filled.length equals 0. Then we're going to say, there's actually a couple of extra conditions we're going to check. So let's do this. Or filled.char at, so now that we know that if we get to this part of the or statement, then we know that it wasn't null and its length wasn't 0. So there's going to be a char at 0. Not equal to, actually let's do this uppercase stuff. I'm going to actually make this a little bit easier to read. So if it's not y, is this the best way to do it? No, let's break up this logic so it's easier to watch, easier to understand. So let's get rid of this stuff real quick. We'll come back to that. And then we're going to say, system.error.println filled must be either y or n. And then we're going to system.exit again. And now we're going to check and make sure that they give us a y or an n. But there's actually a shortcut that we can do, and I'm totally fine with it. We can define our rule to say, if it's not yes, then it's false. If it's a y, then it's going to be true. If it's anything else, then we're going to call it false. That's a shortcut that we take a lot of times, unless you really have to be that stringent where it's either a yes or a no, a y or an n. In our case, it's going to be okay if we just do check for y. If it's y, then filled is true. If it's anything other than y, then it's going to be false. So we can actually set that case to, we'll start with the default case. We're going to say Boolean is filled equals false. That way we don't have to make an extra else in our if statement. And then we just say if filled, we already know that there's something at char position 0. So we're going to say filled.to, and let's go lowercase this time because there's a lowercase and it feels bad if we don't call it once in a while. Dot char at 0 equals the lowercase y, then is filled equals true. Why did I do the char at thing here? The reason is because I read in the entire line because I just wanted to be sure that I got whatever the user typed in. I could have ignored it, but because in your program, you're going to be reading 3 different triangles from the user, you can't afford to let the user leave anything in the input buffer. So that's why I read to the end of the line, because that takes all the way up to where they hit the enter key when they type the input. And you would be wise to do that in your program. Okay, so now I've inputted everything and I've validated everything. And because I'm taking the simple approach for this example, I'm not in a loop, I'm not in a method. I think you would want to do this in a method, or at least in a loop so that you only have to do it once. But I've got all my values, and now I just have to create my rectangle object and then call its toString method. So I'm going to say rectangle rect equals new rectangle, and you're going to see there's actually a lot of rectangle objects available to us. They're all in java.awt, which is a graphical user toolkit that we're not using. So we're going to take the default package that happens to be the one that's in our current directory. So we're going to take that one, and then it's going to tell us here in just a second what's required. Oh, that's right. We have 2 constructors. One's a simple constructor and one is the non-simple constructor, the required constructor. So let's do this the required way, and then I'll show you how to do this the flexible way. So if I hit Command P here, it'll tell me, oops, I need to pass the length, the width, the string, the color, and the is filled. So luckily I have variables of those names, length, width, color, and filled. Oops, filled was a string and I converted it to the is filled, which is a Boolean. Okay. And now I can simply print it out. System.out.println rect.toString. I don't have to call it toString, but I did in this example. And if I run this, it's going to prompt me for my inputs. It's always nervous when you hit that run button the first time. And let's see, oh, I need a new run configuration for this one. That ran my inheritance demo. So I just need to create a run configuration by right-clicking and choosing run first. See, there's always something to be nervous about. So I'm going to enter the length. The length is going to be 4. The width is going to be 5. So my area should show up as 20. The color is going to be blue because that's my favorite color. And what happened there? We got our is filled as well. That doesn't seem right. We're going to have to debug this and figure out what's going on here. Yeah, color must not be blank. Why was color blank? Because now I remember why. And you might not have ever found this. So I hope that at this point, at what is this, minute 56 of the video, and I'm going to write that down and make a note because I'm going to point you to minute 56 because this might be a problem that you're all going to have. Because I'm reading doubles here, they're not actually consuming that enter key. And so when I got to read the color, there was still an enter key sitting in the input buffer after it read the double. And so the next line reads until the next enter key, which it found immediately. And so what I need to do is I need to consume or clear out my scanner. So I'm going to say input, and I forget what the method is, but it's always something. It's something like, we'll do this. If input.has next line, then input.next line. That'll just read through our extra carriage return there before. And then when we read the color, that'll consume that extra line, and then we will also include the, when we read the is filled, we're reading the next line. So that should take care of us. All right, length 4, 5, favorite color is blue. Is this filled, yes or no? I'm going to say yes. And then I get my output, created on Saturday, March 7th. Hey, that's today. My color is blue, and it's filled is true, and its area is 20. And there's my output. But I promised I would show you the flexible way, but the responsibility that comes with it. So I'm going to say rectangle, rect2 equals new rectangle. And now I haven't set anything. And if I call system.out.println on rect2, what am I going to get? First, I have to go through my inputs again. I don't mind doing that. So 4, 5, blue, and yes. Then here's my second output. My color was white, my filled was false, and my area was 0. And why is that? Because I didn't provide any of that input data to my rectangle. So let's say rect2 dot, and the length equals, oops, I can't call dot, I have to call set length and pass it my length, and my rect2 dot set width and pass it my width. Now I can calculate, if I spell it right, if I calculate the area. And hopefully you're sitting there saying, wait, stop, there's more you have to set. 4, 5, enter the color, and that's going to be blue, and the filled is, we're going to say no this time just because. And so that second one, I got the right area, but my color's still white and my filled was false. I won't know whether filled was false because I said no or not, but I know it's because I didn't actually set it and the default value is false. I'm going to say rect2.set filled is my is filled, and my rect2.set color as my color. All right, so that is going to give us everything we need. And you'll see right here what the actual responsibility is that comes with being flexible. If I only ever use my default constructors, I'm responsible to set everything manually to initialize my object so that I get the expected results. If I don't like doing that, then I can use the version of my constructor that makes me pass everything in. And that's actually safer. So when you need safety critical software, we're going to use those inflexible constructors. One other thing I want to show you before we're done is in the assignment, the triangles in the description or the example, it wants you to enter the sides of the triangles all on one line. And so I'm going to modify my rectangle to do just that, and then we'll be done for the day. You can get on to doing this assignment. So enter the length and width of the rectangle. And then I don't need that prompt, so I'll get rid of that line, and I'm going to read 2 doubles in a row. And then this check for the end of the line should be fine, and then everything should work great. So if I run this, and let's just do a line of output here to separate the 2 outputs. Public, not public, lost my train of thought there. System.out.println, just an empty line there. And here we go. enter the length and the width, 4 and 5. And I'll hit enter the color, blue, and the filled is yes. And there's my two versions of my output, exactly what I expected. So I want you to walk through this code in the debugger, or your code in the debugger, and step through it and see how that inheritance works when you're calling that toString method. Because that toString method calls the base class toString method, and you're going to actually see it hop up into there. And so I'm going to leave that as an exercise to the reader. I'm also going to remind you that your program is going to ask for 3 different triangles, and therefore you're going to have this input logic executed 3 times. And please do not copy that input logic 3 times. I don't want to grade that, and I will take points off because we know how to make this efficient. You could put this in a loop. You know, while count is less than 3, and you're actually, and I'll show you this little bit here, you're going to have to declare an array list. We want you to use an array list. So we're going to say array list of the parent class, geometric object. And of course it helps if you spell it right. And we're going to import array list. You'll see here when I come up here and hover, we'll import the class. So it imported up top. Array list objects equals new array list of whatever type we set on the left is going to be inferred here on the right. It's a shorthand because we got tired of typing geometric object too many times on the line. And then you can have a while loop that's going to say while objects dot size is less than 3. You're going to do all this inputting. And when you're down at the bottom, before you do your outputs, you're simply going to do the, you're going to do objects.add. In fact, I'll show you real quick here because I don't want to leave you hanging. You're going to say objects, which is our list of geometric objects, add rectangle. And that'll be the bottom of your loop. And then you will break out of, so you won't actually have this print line. You can finish your input with a try scanner because if you declare your array list outside of your while loop and your try, then it'll hold on to your objects outside of those scopes, and then you can just do a for each on your list of objects and print line the toString of each of those objects. So there you go. I expect you'll have questions. I really hope that you'll ask them where it's necessary. Let me just undo and get back to the stable state so I can post this to the discussion board. And I think we're good to go. So I appreciate your hanging in there for an hour and 5 minutes. Hopefully you will see the power of this type of programming. I think you will definitely see the power of it as we get to next week, and I'll give you a quick preview. The reason why we waited until the end of the semester to teach exception handling or error handling in Java is because the exception model that we use to pass errors through our code is extremely object-oriented, and its inheritance model is crazy. And so this is just a demonstration. You're not going to have to memorize any of this. You just have to understand that the reason we waited until the end of the semester is because we needed you to understand objects and inheritance so that you could understand exceptions. Anyway, that's it for the week. Thank you so much, and I'll see you in the discussion boards.